This example is a lot like the first, but a little bit different, and that's why it's a new example. In this equation, we have y equals 4 over x plus 1, and then we're going to subtract 2 at the end. So this is going to be a little bit different than the last one because of this minus 2 thing going on. Maybe think about what that might do, and pause if you want to ponder what goes on or make a prediction, and we'll see how it goes. The first part of this is going to look almost exactly the same as our previous example. For our vertical asymptotes, we're still going to set the denominator equal to 0. I just have one denominator here, x plus 1. So we'll solve x plus 1 equals 0, and I'll have a domain restriction at x equals negative 1. So we're going to first put our vertical asymptote right there at x equals negative 1. Next up, the y-intercept. Again, similar process, same thing as what we did before. I'm going to set the x equal to 0. So let's do that. I'll take y equals 4 over 0 plus 1 and then minus 2. Or this is going to equal 4 minus 2, which is equal to 2. So I'm going to have the y-intercept 0, comma 2. We'll put that guy on here, 0, 2. And let's even label that 0, comma 2. Next up, let's take a look at the x-intercept. This is going to be a little bit more work this time around. But I have 0 equals, well, I'll set the y equals 0. And actually, just for the sake of having more room, let's do that up here. So 0 will equal 4 over x plus 1 minus 2. If I were to solve this, I'm going to add 2 to both sides. So I get 2 equals 4 over x plus 1. And now let's kind of cross multiply, or you can think multiply both sides by an x plus 1. That's going to cancel those x plus 1s. So then let's go over here. I'll have 2x plus 2. I distributed that 2 through to both of these terms. Equals 4. I subtract 2. I get 2x equals 2. And finally I get x equals 1. So that means I'm going to have actually an x-intercept at the point 1, comma 0. So that's pretty exciting. I didn't have one of those before. So there is my x-intercept at 1, comma 0. Nice. Okay, end behaviors. This is where it starts to get a little bit interesting. So again, I have my limit as x approaches negative infinity of the function that we are calling y, or of the y values. That's what we're interested in looking at. Now, if I were to remove this 2, if I just kind of cover this up, and let's actually do that for a second. If I were to cover up this 2, let's see, can I fill it with something? Yeah. All right, I want to hide this thing. If that 2 didn't exist, this is exactly like the last problem that we had, where if I plug in really, really big numbers, this fraction becomes really, really, really small, and it's approaching 0. So you would think maybe off the first glance like this might equal 0, but what is the difference that this minus 2 makes? If I get rid of this now, and now this actually is subtracting 2, after I've gotten this really, really, really small number that's almost like it's approaching 0, I'm going to then subtract 2 from it. So really what's going on is everything that happened in that previous video with the first graph, the same thing's happening, but I'm just taking 2 away from each one of those scenarios. So what does that mean? As my numbers are getting as these fractions are getting really, really small, as x is getting really, really big, my y values are approaching negative 2. Oops, let me try that again with a pen. My y values are approaching negative 2. Before, if I covered up this minus 2 and you imagine it wasn't there, my y values get closer to 0 as this fraction gets really, really small. But I'm subtracting 2 from all of that, so I'm approaching that negative 2 instead. And the same thing is true with the limit in the positive direction. The limit as x approaches infinity of y is going to be negative 2. And if that doesn't make sense, pause the video and ponder that a little bit. Maybe even plug in some values and see for yourself what I mean. If you didn't have that minus 2, you would be approaching 0, but because you're subtracting 2, you're moving everything down. You can also think of this as like a function transformation. This is a function, 4 over x plus 1, and I'm just subtracting 2. I'm just moving all of my y values down 2 places. All right, so that means that my horizontal asymptote, I'm still in the dotted line mode, the horizontal asymptote will be y equals negative 2. This is where I'm approaching, so that is my horizontal asymptote. Now I'm ready to graph this thing, and I already have a couple of points to work with here. So I'm going to connect these 2 points and get a graph that looks like this. and I'm going to connect these two, or rather I'm going to draw a shape in this opposite quadrant here, and that's my picture right there. So now it's ready, or now you're ready to try some of these on your own. So I would say pause the video, give this problem a shot. When in doubt, you can always plug in values if you're not sure what the picture looks like, but give this your best shot, and then resume when you're ready to see. All right, so here's all of my information, and here's what my graph looks like. Hopefully you got something pretty close. The main parts are that you got the asymptotes correct, and that you've got these intercepts correct. So hopefully it went well. Here's another one, kind of similar, but a little bit different. And watch out for this negative sign here. That does have an impact on the way things work. So give this problem a shot, and we'll see how it goes. All right, here's my solution for this U-try number 5. Hopefully it went peachy keen. In the next video, we're going to keep doing more graphs. We're going to just turn the dial up a little bit, get a little bit more complex, and we'll see how it goes.